students. So we are going to discuss the problem number 718, and the problem statement says you have to find the maximum length of repeated subarray. Okay, so basically we have given two integer arrays nums1 and nums2, and we have to return the maximum length of subarray that is common in both of them. So let me explain the nums1. We have given 1 2 3, then 2 1, and in the nums2 we have given 3 2 1 and 4 5. Okay, so if you see this part and this part, so basically this is common in both of them. The maximum length of subarray which is common in both of them is 3. Let's take the another example. So we have all the zeros. So in the first array we have 3 zeros. In this, like, one second array we have 0 comma 0 comma 0. So in this case output should be 5, okay, because this whole array is equal to this one. So what are the different approaches could be for this solving this? The first approach, which is the brute force. So let me write the array again. So this is array 1. We have 1 comma 2 comma 3, 2 comma 1, and array second we have 3 2 1 then 4 and 5. Okay. So what could be the simplest approach? So simplest approach could be like, let's start from this one first. Basically we will iterate our first array and we will check if this element is equal to any element in the second array or not. If it's equal to any element, then we will start another loop. Basically it will traverse both the array until it finds the common elements. Okay, so we have started with I equal to 0. We have checked in I2 it's not equal, then we will go at the second place in J. We will check again, it's not equal, then we will go at this one. 1 and 1 is equal, so we'll start another loop which will traverse from 2 or 5, and if they both are equal then it will goes on incrementing. So basically 2 is not equal to 4, so this loop will break, and then we will come at 4. We will match 1 and 4, they are not equal. We will match 1 and 5, they are not equal. Then we will increment the I pointer, and then again we will start from J0. We will match 2 with 3, they are not equal. Then we will increment the J pointer, then we will match 3 and 2. Then they sorry, we will match 2 and 2, they are equal. Then again we will start matching, starting a loop, and so on. Let's see the code for the brute force approach. So basically in approach, we have one for loop which iterates on nums1, and then we have another for loop basically which iterates on nums2, and then if you find any match like I nums1 of I is equal to nums2 of I, then we are starting another loop basically which matches all the elements until we are getting a mismatch, or basically no. Okay, so and after that basically we will find the maximum subarray. We have maintained a variable max subarray length which we will increment on the basis of k. So if you think of time complexity, so we have one loop for I 1 2 nums1 dot length. Then we have another for loop j, which is going from 1 to nums2 dot length. Then we have another while loop, which is k. The max it can go from 1 to n every time. Okay. So if you think of time complexity, it will be order of n cube. And let me run this so that you will get a feel. So basically, if you try to run it, submit it, basically you will get the time limit exceed option. Limit exceed option. So let us see how we can optimize this. We have one array is 1, 2, 3, 2, and 1. Then we have another array which is 3, 2, 1, or simply let's say a 4. So let's create a matrix. So let's say we have 1, 2, 3, then we have 3, 2, 1, then 4 and 5. So basically in this matrix what we are capturing the maximum length when we have only one element in nums2, only two elements in num2, and so on. So the cell will contain the maximum length of common subarray when in nums2 we have only one element. Okay. So suppose in nums2 we have only 3. So what we can do, like if 3 and 1 are equal, they are not equal, so let's put 0 here. 3 and 2 are equal, not equal, then put 0 here. 3 and 3 are equal, so let's put 1 here, then 0, then 0. Now we have two elements in this array, nums2, and we have complete nums1 array. Okay. So we will match the 2 with 1, which is 0. We will match 2 and 2. Now 2 and 2 is matching, so we will check the subarray which is lesser than it. So 2 and 2 will, we have cell number as 1 comma 1. We will check cell number 0 comma 0. Whatever value we have, it will be greater than 1 by it. So in the 0 comma 0 we have 0, which is matching. So we will put the value as like matrix of 0 comma 0 plus 1. Okay. Now we have 2 comma 3, there is no match, so we will put 0. Then we have 2 comma 3. Okay, they both are matching. In this case the cell number is like 1 and 0, 1, 2, 3. It's 3. We will go diagonally and check what is the value at the diagonal element. So we will check at 0 comma 2. 0 comma 2 we have 1, so we will put 1 plus 1 in this element. And then we have 2 comma 1 which is not matched, so we will put 0. 1 or 1 which is 1, 1 or 2 not match, 0, 1 or 3 not match, 0, 1 over match, go to the diagonal element which is 2, so we will put 3 here. Not match 0, not match 0, not match 0, and so on. This will be also 0. After completing this matrix, whatever the maximum value we will get, that will be our answer. Basically what we have done, we have created a matrix of size n cross m. Okay, where n is the length of first subarray and m is the length of second subarray, and we have populated this matrix Yeah, we have seen how we can optimize using a matrix, and let's discuss about the code of this optimized approach. So basically, in this, we will have two for loops. One for loop which will iterate over the first array. Then we will have second for loop which will iterate to the second array. And then we will have matrix that will store the maximum subarray length till that element. Yeah, so basically have reduced the time complexity from order of NQ to order of N square. And let me submit this. So basically, yeah, it get accepted and the runtime is 101 milliseconds.